All right, questions 7 through 9, you are given either the area of the shaded region or the length of the arc. You're going to use it to find the radius. So when we do these problems, we want to be careful that we can't go straight from sector area or arc length to find radius, but we need the corresponding whole circle measure. So either the whole area or the whole circumference. So if we look at problem 7, I'm given the sector area, so I'm going to need to find the area of the entire circle. I know that my central angle of this sector is 90 degrees because of our right angle box. So I'll set up my proportion 90 over 360, and that's going to be equal to the sector area, 4 pi, over the circle area. And I know the area of a circle is pi r squared. All right, so I'm just going to write pi r squared because the only thing I don't know about that area is the radius, or the radius squared. So I'm going to cross multiply, but before I do that, I know that 90 divided by 360 is 1/4. So just to make my math a little easier, I'm going to simplify this and multiply, use 1/4 instead of 90 over 360. You should get the same answer no matter what though. All right, so when I cross multiply, on the top I have 4 times 4 pi, not on the top, but I guess from 4 to 4 pi, and then 1 times pi r squared, which is just 1 pi r squared, or just pi r squared. All right. So from there, if I simplify this, 4 times 4 pi is just 16 pi. You can treat pi almost like a variable, and that 4 times 4 pi is just 16 pi. Kind of like 4 times 4x is 16x. And this is equal to 1 pi r squared, or just pi r squared. So anytime I have pi on both sides of my equation, I can basically divide them off of both sides. So I'm trying to isolate my radius squared. So I could divide off by pi on this side, and anything I do to the right, I'll have to do to the left. Divide by pi, and I'm left with 16 equals r squared. So again, our goal is to find the radius. I just take the square root of both sides, and 4 is equal to r. So we found the radius, and the radius is 4. All right, question 8. In question 8, we're finding the radius again, but we're given the arc length. So remember, arc length goes with circumference. So we found area of the last one. We're going to find circumference. We know circumference is pi times diameter, or 2 pi r. Since my goal is to find the radius, it might help to use this form of the circumference equation. So I'm given my central angle, which is 36 degrees, the ratio of 36 over 360. Now if you want, you don't have to simplify that, but that's the same as 1/10. And again, you could put that in your calculator and hit math enter to get a simplified fraction, or a common fraction, I should say. All right, so 36 over 360, or 1/10. I'm going to compare that to the arc length, which I know is 4 pi, over the circumference, which I don't know, but I know that I can represent it with 2 pi r. Now you could use pi d, but then we'll have an extra step to get our radius. All right, so again, we said this is the arc length, this is the circumference, and then this is the simplified ratio, but this is our central angle, and this is our whole circle. All right, so whether you use 36 over 360 or 1 over 10, we should get the same thing. When I cross multiply, and again, it's not the only way, but it's a way we know how to solve proportions, I get 10 times 4 pi equals 1 times 2 pi r, 2 times pi times the radius. I know this can look really complicated, but 10 times 4 pi is just 10 times 4 times pi. So 40 pi. And then we really don't even need that 1 there. Our identity property tells us that anything times 1 is itself. So this is just 2 pi r. All right, now there's a lot of ways you could solve this. You could divide both sides by 2 pi, or if that is intimidating, we could just start by dividing both sides by pi, because we ultimately want to get r by itself. So if I divide off those pi's, I now have 40 equals twice the radius. Now if I divide off the 2, 20 equals the radius. So the radius is 20. So if the radius was 20, we can go back and think about this. That means the circumference was 40 pi. So 40 times pi, twice the radius times pi. And that should be, the arc length should then be 1/10 of that. So if our arc length was 4 pi, 4 is 1/10 of 40. So that works out. All right, we did number 9 in class. I am going to go over it in this video. If you feel good about it, you can just skip it, but it's here for you. A lot like question 7, we're given the sector area. We are going to need to find the actual area of the circle to be able to answer this question. We can't get the radius from the sector area. So we said our central angle is 45 degrees. And we're going to write 45 over 360. And if you want, you can simplify that. I know 90 goes into 364 times, and 45 is half of 90. So I really have 8 45-degree angles in a circle. So this really simplifies to 1/8. You don't have to reduce it, but you can. All right, we know that our sector area, because we said this is our central angle, this is our whole circle. So I want my sector area on top, which is 32 pi, compared to the whole area, which is pi r squared, because we don't know the radius of the circle, but we're going to find it. All right, so now I could cross multiply. All right, I've got 1 times pi r squared, which is just pi r squared. And then I've got 8 times 32 pi. And so I've got to multiply that. Let's see. 8 times 2 is 16. 8 times 30 is 240. So this should be 256. Or you can just use a calculator. All right. So we get 256 pi. We could divide both sides by pi to get r squared by itself. Now the radius squared is equal to 256. Take the square root of both sides. The radius is equal to 16. And I'm realizing I didn't put units in any of these. So this should be 16 centimeters because a radius is a linear measure. This should be 20 centimeters because we were given an arc length of 4 pi centimeters. And this should be 4 centimeters. All right, the next video we'll go over questions 10 and 11.